Hello again, 8th graders. Filling up the final piece of the puzzle with radicals. Now we deal with radicals that are involved in equations. This is lesson 106, solving radical equations. And in many ways, solving radical equations is just the opposite of what we've done with equations like this, where we've had a squared term equals something. And we simply use the square root to unsquare something, and we took the square root of both sides to give us an answer of just plain old x. Alright? So in this case, we start off with the variable inside the radical. And as you might suspect, as you now know, to get rid of a radical sign, you square it. And what you're left with is what's inside the radical. So, to solve radical equations, the basic way to do it is to square both sides and get rid of the radical sign. So if I've got the square root of x equals 7, then I'm going to square the square root of x. But remember, you got to do that to both sides. And then I square 7. And we see that the square root of x squared is x. 7 squared is 49. And here's where you got to get in the habit of checking your work, all right? Remember we said the square root of x equals 7, and now we say x is 49. Then it better be true that 49, the square root of, better equal 7, and it does, so it checks out. This checking your work thing is going to come in handy later. Alright, so let's look at some other radical equations, alright? The square root of 4x equals 12. Well, notice that this is nice in that there's going to be a pattern here, and that is we're going to have the radical on one side, just the radical, and everything else on the other. And that's going to come in handy later. So if I got the square root of 4x equals 12, then 4 times something is going to give me some big number, and then that big number has to be a square root that has to equal 12, right? So we get rid of the radical sign, we square that, and we square that, so that we're left with what's inside the radical sign. 4x equals 12 squared, 144. Dividing both sides by 4, x equals 36, and we check our work. If x is 36, then 4 times 36, which just happens to be a perfect square, 144, square root of 144 equals 12, it works. All right? If we've got multiple terms inside the radical, doesn't really change anything. We're still going to square both sides to get rid of the radical sign. That gives me what's inside the radical, x plus 2 equals the number squared, 144. Subtract 2 from both sides, and x equals 142. And you go, does that work? Well, 142 plus 2, that's 144. Square root of 144, 12, it works. Okay. It doesn't matter whether we've got multiplication or division in here. If we start off with the square root of x over 2 minus 6 equals 8, we're going to square both sides. Just gives us x over 2 minus 6. What's inside? Remember, squaring it gets rid of the radical sign, but you got to do it to both sides. You get 64 there. Add 6 to both sides, multiply both sides by 2, and you get x equals 140. Now, is that reasonable? Does that make sense? I mean, you have to ask yourself these questions. All right? So you go back and check your work. X, you say, is 140, so 140 divided by 2 minus 6 in a radical sign should equal 8. 140 divided by 2 is 70. 70 minus 6 is 64. Square root of 64 is 8. So x equals 140 works. All right. Now, sometimes you've got a radical, a non-radical, and no more non-radicals. Remember, the pattern is you have to isolate the radical. All right. You isolate the square root. You get that all by itself. Here, it's not all by itself. All right. And so we're going to add 3 to both sides. And now we've isolated the square root. You've got the radical all by itself, so we can square both sides. X equals 121. Is that true? Square root of 121, 11 minus 3 equals 8. It works. All right? So if the radical is not by itself, you got a little bit of manipulation to get it by itself. All right? Here, again, the radical is not by itself. We would not just square everything here. All right? Let's divide everything by 3, divide by 3. And now I get the square root of x equals 7. So squaring both sides, x equals 49. So is it true that the square root of 49, 7 times 3 equals 21? It works. Takes about 5 seconds to check your work here. Well worth it. All right? Once again, the radical is not by itself. It's being divided by 2, so we do the opposite. We multiply everything by 2. We get the square root of x equals 36. Now we can square both sides. X equals 36 times 36, whatever that is. And I would suspect that I put in 36 times 36 here. I'd get 36 as the square root. Divide that by 2. You get 18. X equals, 36 squared works for that. All right? All right, sometimes you got radicals on both sides. Big deal. I mean, you got something like this radical equals that radical. What do you think you're going to do? Yeah, you're right. You're going to square both sides. And so when we do that, all right, we're going to simply take this and square it, take this and square it. And that gets rid of the radical on both sides. We get rid of 2 radicals in one step. And leaves us with x plus 2 equals 2x plus 4. And let's see, we can subtract x. 2 equals x plus 4. Subtract 4 minus 2 equals x. And, ooh, negatives in the radical, does that work? Well, let's see. If x is minus 2, then minus 2 plus 2 is 0, and the square root of 0 is 0. So we got 0 on this side. 2 times minus 2 is minus 4. Minus 4 plus 4 is 0. We get 0 on this side. It works. All right. All right, look at this. Here we've got 2 radicals, but there's a problem. Let's see if we can get the radicals on one side and the other. In other words, I'm just going to rearrange this and add root 2x to both sides. I just took this and jumped it over, all right? And now I've got radicals on both sides. So I'll get rid of the radical sign by squaring. So I got x plus 2 equals 2x. Subtracting x from both sides, 2 equals x. Does that work? Well, the square root of 2 plus 2, that's 2, minus 2 times 2, 4. The square root of 4 is 2. 2 minus 2 is 0. It works. All right. Same type of problem. 2 radicals and a 0. So I'll add root 3x to both sides. So that now I've got root x plus 4 equals root 3x. 2 isolated radicals. Square them both. X plus 4 equals 3x. Subtract an x from both sides. 4 equals 2x. Divide both sides by 2. 2 equals x. And very quickly ask myself, does this work? If I have 2 plus 4, that's root 6, minus 3 times 2, root 6. Root 6 minus root 6 equals 0. What do you know? It works. All right. Now sometimes you wind up with these extraneous solutions. All right. We see something like this, all right, which is slightly different. You have to be aware of that. We've got a binomial on the other side. And so, indeed, we want to get rid of the square root. So we're going to square both sides, but now watch what happens. All right? I square this, and I have to square the whole other side here. I have to square x minus 3 times x minus 3. And so here, this square just gives me what's inside the radical, x minus 1. And here I have to FOIL. First times first, minus 3x, minus another 3x, minus 6x. And last times last, minus 3 times minus 3 plus 9. So now I've got a quadratic going. All right, so here's where I was. All right, so now solving quadratic equations, remember that you want to get it in standard form, so you want to get everything over to one side and have it set it equal to 0. So I'll add 1 to both sides. That gives me x equals x squared minus 6x plus 10, one more here. And then I'll subtract an x from both sides to give me 0. And that x will be taken away from minus 6x to give me minus 7x. So now I've got this quadratic equation. And yes, you can pull out the old quadratic formula and do minus b plus or minus the square root of b squared minus 4ac all over 2a, and you get an answer. But you might recognize this as factorable, what multiplies together to make plus 10 and adds together to make minus 7, minus 5, minus 2. Much more preferable. You would have gotten the same answer if you'd used the quadratic formula. So we've set these factors equal to 0, x minus 5 equals 0, x minus 2 equals 0. Solve for x is 5 and x is 2. So now we've got two solutions to this problem. All right? Is one right? Are they both right? Or none of them right? Well, this is where checking your work for extraneous solutions comes in. If I say x equals 5, and I go back to the original thing and substitute in for x 5, and x here, remember that was x minus 3, and I substitute in 5, I get the square root of 4 equals 5 minus 3. Oh, 5 works. But now if I do the same thing for the other solution, 2, I get 2 minus 1, that's the square root of 1, equals 2 minus 3, minus 1. Well, the square root of 1 is 1, not minus 1. 2 doesn't work. So we say that 2 is extraneous, and the only solution to this equation is 5. Okay? Let's try another one. All right, so again, we've got a radical on one side, so we want to square it to get rid of the radical sign. That's going to give us 7x plus 15 equals x plus 1 squared. All right? So 7x plus 15 equals x squared plus 2x plus 1. Right? 1x plus 1x, 2x, 1 times 1, 1. All right? Now we want to get everything over so we can set it equal to 0. 7x, I'll subtract 15 from both sides. X squared plus 2x minus 14. All right? Subtracting 15. And now subtracting 7x from both sides, I get 0 equals x squared minus 5x minus 14. All right? And I look at that and ask myself, is it true? Are there anything that parentheses x multiplies together to make minus 14 and adds together to make minus 5? If it doesn't factor, then we use the quadratic formula, but in this case, I believe we can do parentheses x, and multiplies together to make 14 and gives me a minus 5 would be minus 7 and plus 2, all right? Because then you got minus 7x plus 2x minus 5x, and here minus 7 times 2 minus 14. We set each one equal to 0. And so x equals 7 and x equals minus 2. Once again, we have to check, do they both work? Does one work? Or could neither one of them work? So if x equals 7, we got 49 plus 15. That would be 64. Square root of 64 is 8, and 7 plus 1 is 8. What do you know? 7 works. What about minus 2? 7 times minus 2 is minus 14, plus 15 gives me the square root of 1, that's just 1. And then minus 2 plus 1 gives me minus 1, 1 isn't minus 1, so minus 2 is extraneous. You write both x equals 7 and x equals minus 2, you get it wrong. Because it only equals 7, we say minus 2 is an extraneous solution that gets thrown out. All right? Let's look at another one here. All right, looks simple enough, right? Isolate the radical. Square root of x equals, subtract 5 from both sides, minus 7. Square both sides, x equals minus 7 squared, 49. Okay. We put it back in the equation here. The square root of 49 is 7 plus 5 equals minus 2. What's going on here? That's not right. There is only, we've only got a linear term here to the first power, so we can only have one solution. It's not quadratic. But in this case, that one solution, x equals 49, doesn't work. So x equals 49 is extraneous, and so we say there are no solutions to this. There is no number x that you take the square root of, add 5 to it, and you get minus 2. And maybe you could see that now, because the square root of x would have to be negative, right? It would have to be more negative than 5 to combine with the 5 to make a minus 2. And anything coming out of a square root sign is not going to be negative. So in this case, there is no solution to that. All right. Here's another example. Once again, looks simple. Fine, we'll just subtract 6 from both sides, and the square root of x equals minus 9. Square that, x equals minus 9 times minus 9, 81. That's nice. I mean, we don't want a minus inside the radical. So the square root of 81 is 9, and 9 plus 6 is not minus 3. So once again, we have a single solution that doesn't work, so we say there is no solution possible to this. Again, looking at this, the value of the square root of x would have to be much more than minus 6. The value of the square root of x would have to be minus 9 to add 6 to it and get minus 3. But you're not going to get any real number that square root is minus 9. All right. So, all right, with that in mind then, give this all a try. Give this a Aggie assignment, lesson 106, A and M. A through M, I should say.